Okay, let's review one more thing here before we move on. When you have a triangle that has a midsegment, like we've been working on, these will be the same, and these will be the same. So let's just make let's make it very clear. If this is 6, then this would have to be 6. And if this is 10, then this has to be 10. They have to be equal. Otherwise, it wouldn't be a midsegment. So if they tell you that you have a midsegment, then you know that these two will be the same, and these two will be the same. They don't have to be the same number. All four of them don't have to be the same number unless they tell you one more thing. Let's say, let me draw that again. Let's say that they tell you not only does it have a midsegment, but that it's a midsegment of an isosceles triangle. Now that changes everything. Because if it's a midsegment of an isosceles triangle, then that means that this side is already the same as this side. Which means if this is 5, then and this is 5, then so is this. But that's the only way that that would be true. The only way that they would all four be the same number is if you had a midsegment of an isosceles triangle, or an equilateral triangle for that matter. But either way, but just know that that could happen. Another thing that you need to be made aware of is that when you have a midsegment, you also have similar triangles. I'm going to shade this one, the small one, in red, okay? So I'm going to redraw that. That's that same triangle, okay? Now I'm going to draw the big one again. These are also similar triangles. They're just, the little one's laying on top of the big one. If you remember about similar triangles, then you'll know that not only, well, the sides are proportional, but the angles are the same. So this angle would be the same as this one, and this angle would be the same as this one. And of course they share that top angle because it's in both of them as it is anyway. So remember that. Let me draw this again, try to make it a little bit easier to understand. Okay, so let's say that I have the two triangles and they're overlapping again. This is the small one, and then there's another one, a bigger one underneath of it. In the small one, we have the two angles marked. This one is 80 degrees, and this one is 70 degrees. So what that means is in the big triangle, this one is 80 degrees, and this one's 70 degrees. Of course, they share that top angle, which would be 30 degrees. But we knew that anyway, because even if it was over here, they would have to be both 30 degrees, because literally it's laying on top of the other one. So you have a couple things here that are going to come up in today's assignment. You could be dealing with angle measures. You could be dealing with congruent line segments, meaning that it's an isosceles triangle. And you could be dealing with just normal finding the midsegment length. So I want to do 5 with you, and then you can do the other number 5 with you, and you can do the other 5 by yourself. So take a minute and just look at the problem first and see if you know how to solve it. The first thing that I would do is take care of the midsegment, because it's the easiest part. I know that 2x plus 3 is half of 9x plus 44, minus 44. So 2 of these, 2x plus 3, equals 1 of the 9x plus 44. I keep saying plus, it's minus. That would change everything. Okay, I have it right now. So, again, 2 of the midsegments equals 1 of the long side. So I'm going to combine like terms. I'm going to get 4x plus 6 equals 9x, I keep saying plus, minus 44. Okay, so we're just going to solve like normal. Go subtract 4x. I'm going to get 6 equals 5x minus 44. I'm going to add 44. And then I get 5x equals 50. And that means that x equals 10. Okay, so now we're going to go back to the original problem. We've solved for x, so that part is done. Now let's look at the other. We're going to solve for y. But notice they have these degree symbols here. So that means that we're not talking about midsegments here. We're talking about angle measures. And here's what we know. That these two angles are the same. Whatever this angle is, which is y plus 12, equals whatever this angle is, but they don't give us any information on it at all. So we can't use 3y plus 8 because that's the exterior angle. You know, that's this big angle on the outside. But what we do know is those two angles together make 180. So 3y plus 8 plus some unknown equals 180. So what we can do is we can subtract this 3y minus 8 plus 8, from both sides, and that'll give us what this unknown is. This is what we need to know. So we're actually going to write it just like that. It's going to seem very weird if you've never done it before, but this angle, because we don't know what the expression is, what we do know is if we took 180 and subtracted it, that's what it would be. And so watch this video again if you need to rewind it, listen to that again. It's a useful tool, but it can be very confusing the first time you do it. Let me just say it one more time here. The only thing that we knew is that these two together make 180. So to give this a name, to give this angle some type of name or some type of useful measurement, we had to say the only thing that we know is that if I take 180 and I subtract away the expression that they gave me, it would give me the unknown expression. And that's what we need to have, because the only thing we know is that these two are congruent. So what you're going to do is you're going to solve this equation, and that'll give you what y is. Most of the kids, where they mess up, if they get this far, is that they don't distribute this negative. You're subtracting both of those things. You're subtracting 3y and you're subtracting 8. They usually just subtract the 3y and they keep the 8 positive. But when there's a negative out front of the parentheses, that negative goes to everything. It changes the sign of everything in the parentheses. So for example, if I had a negative out front of this parentheses, the result would be negative 2x minus a plus c. Notice it changes the sign of everything in here. This was a positive, now it's a negative. This was a positive, now it's a negative. This was a negative, now it's a positive. So make sure that you realize anytime there's a negative out front of a parentheses, it's just going to get distributed to everything, and everything's going to change its sign inside of the parentheses. So I'm going to go ahead and finish writing it. So y plus 12 equals 180 minus 3y minus 8. I'm going to give myself some more room, and I'm going to combine like terms on this side. So 80 minus 8 is going to be 172. And then I still have y plus 12 over here. 3y is actually smaller because it's a negative 3y. Notice that it's a negative 3y here, so we're going to add 3y to both sides. These 3y's will go away, and I'll get 4y plus 12 equals 172. And then I'm going to subtract 12 from both sides. And these 12's will go away, and I'll get that 4y equals 160. Then I'm going to divide by 4, and I get that y equals 40. And I'm running out of room. But we actually did finish. That's the only thing they asked us for. They didn't ask us for the measurement. We could plug it back in. We could figure it out. In fact, I think I might, just to show. But they only asked us to solve for y, so we did that. But let's go ahead and plug it in and make sure that it makes sense. So I'm going to give myself some space. So y equals 40. So this angle measure would be 52, because 40 plus 12 is 52. And then I'm going to plug it in here. So 3 times 40 plus 8 would be 120, plus 8, which would be 128. So this angle measure on the outside here would be 128. And then this one would have to also be 52. And 52 plus 128 should be 180, and it is. So we did figure it out, and it does work. When we plug it back in, everything makes sense. You know, this had to be the same as this. They both have to be 52. And the outside angle would have to be whatever 52 minus 180, 180 minus 52, which is 128. So there's 5 more problems. They are quite involved, so take your time. There's no answer. You can't tell if you're right or wrong, so just try them. And if you have questions, raise your hand and I'll look at it with you.